Hello dear students, this is Zamir Sheikh, Faculty of Chemistry, and welcome you all in this online lectures. Your first online lecture of organic synthesis, and the topic of our discussion is organometallic compounds, a very well known topic for making carbon-carbon bond and for the as acid-base chemistry particularly, and very essential one can say for functional group transformation. And what, as per your syllabus, in organometallic compound there are three different parts are there. First go through the syllabus. First part is what the organometallic compounds, particularly of magnesium, lithium, boron, silicon, tin, phosphorus, sulfur, lithium, etc. Second part is what transition metals, organometallic compounds of transition metals, and last part is the metallocene. So there are three different parts in the first chapter of your semester number 4, and so today we will see the how this reagent is work, how this reagent is behave. So why this organic chemist particularly very one can say have lots of applications. Why try to find the reagent that will be applicable to transform one to other. So without wasting time, so once again I welcome you all on the behalf of Department of Chemistry. So I hope all of you are doing well and safe at your home. So always do your best, you will never be disappointed. So this is our free channel. If you are interested to do something more about that or eager about the chemistry, so must visit at once. And if you like any content regarding that or in from that video or anything from this channel, so must subscribe and share with your colleagues. Okay, so our first part is what is that organometallic compounds. I already shared my presentation which are uploaded few years back on a slide share, as well the YouTube video on your WhatsApp group. So if any kind of a query regarding that, so you can raise it. Your group is open for our discussion. First of all, what is the how one can define that organometallic compounds? You know that a very simple chemistry is this. Organometallic compounds are nothing but the compounds where metal carbon bond is present. So all of you know that, okay? And you know that based on that your metal and carbon, so one can decide the polarity. Your metals are what generally electropositive, they loses the electron, while carbon is a moderate electronegative, right? So because of what, according to Pauling scale, the electronegativity of the carbon is 2.5. So any compound having metal carbon bond is said to be the organometallic compound, right? So this is the first point, and that is a definition of an organometallic compound. So secondly, what, so due to that polarity, due to that negative charge which is developed on that carbon, so that carbon is act as a source of a nucleophile, source of a carbanion. So either it will be act as a nucleophile or either it will be act as a base. If it is act as a nucleophile, then it works in the carbon-carbon bond formation reaction. Those reactions in which a new carbon bond is developed, so that reaction is said to be what? That reaction is said to be homologation reaction. Remember this point, okay? So here that carbon is what? Source of a nucleophile. That's why it will be reacts with electrophilic center and it can develop the new carbon-carbon bond. And that's why organometallic compounds have what in recently there are lots of application to developing a new carbon-carbon bond. We can develop a complex molecule like natural product and etc. etc. Okay, so we have the lots of application regarding that organometallic compound. So second part is what? Nomenclature. How to nomenclate that organometallic compound. We have numerous metals are there. When metals are attached to that carbon, so basically what it will develop a new form. Okay, so based on that your metal we can classify it or we can nomenclate that. Suppose I have methyl lithium, you know that CH3Li. So this is a very simple formula, and methyl lithium, because methyl is the belongs to the hydrocarbon family, and CH3 means it is a methyl, and your lithium, so it is a name of the metal. So combinedly we can call as a, like methyl chloride, methyl bromide, methyl iodide, we can call as a methyl lithium. Secondly, methyl magnesium bromide, what is that? CS3MgBr. Okay. So other also there are many reagents are there, you can take the example and you can classify it. Okay, it is just the introductory part. Secondly, what are the physical properties? You know that organometallic compounds of S block are quite more reactive. They cannot be used, or they cannot be handled in the presence of what water as well as in the presence of what air. That means whenever we are using, whenever what we want to use that organometallic compound, that compound should be kept in absence of oxygen. Why? Because of these S block elements are reactive, they can easily combine with oxygen, right? And that's why we are always try to avoid that contact of oxygen now. So you know that sodium, potassium, magnesium, etc., they are always kept in the what? Anhydrous environment, environment, inert oxygen, like that. So whenever we are using that organometallic compound, so always we should use the anhydrous kind of what conditions now. Okay, so we have to avoid the contact of what oxygen in the form of water or in the form of what air now. Okay, that's why so we should maintain that condition, neither the reaction becomes an explosive, fine. So secondly, what are the structures of what organometallic compounds? The structures of what organometallic compounds are, we have depending upon type of what metal we are used now. Generally carbon is a sigma donor ligand, it's just act as a sigma donor. Okay, so that means metal carbon bond is always sigma bond, that is single bond is developed between metal and carbon. So whatever organometallic compound is there, either lithium, magnesium, etc., all these compounds generally have the single bond between them. Okay, and due to this based on that electronegative difference, we are classified onto the reactive organometallic compound, middle reactive organometallic compound, or inert organometallic compound, like that. Okay, so if we are using organometallic compounds, from say example first group element, then the difference will be a more, we will take the how to calculate the difference, how to find out the difference. Okay, so just remember that S block organometallic compounds are more reactive than P blocks. Okay, fine. So we have the next slide like this, so you can follow on this channel also. Okay, look, the difference is given here. This is the actual periodic table of our interest. So boron, carbon, nitrogen, then what, oxygen, this is oxygen, then this is the fluorine, and this is what, neon, this is noble gases. If you find that, so if I made the compound of at carbon lithium, then 1.0 will be the carbon and 2.5 will be the what, so lithium and carbon difference will be 1.5. if I take this magnesium and what, carbon, 1.2 and 2.5, 1.3 will be the difference. If the difference is decreased, then polarity will be decreased. If the difference is more, then polarity will be the more. Ionic character will be the more. The more reactive will be the organometallic compound. Okay, so based on that difference, one can decide the reactivity of organometallic compound. So lithium organometallic compound as well as magnesium organometallic compound, they are versatile. What is the meaning of versatile? Like lithium aluminum hydride, already learned in your last semester. Lithium aluminum hydride is a more reactive and less selective type of a reagent. Why? Because of it is a versatile. That means it reduces all the kind of function group. Some exceptions are some. Okay, so like that. Okay, fine. So this is actual picture of what, orbital picture of what three different molecules. How the electron density is distributed on that molecule. So look at the first example is methyl chloride. You know that due to the minus inductive effect, so this region is a red region. This region is a blue region. What is the red region now? The red region nothing but the word where electron density will be the more, where electron density will be the less. You know that in methyl lithium the positive charge will be on carbon, negative charge will be on chlorine. If you take the second example, you will observe that so exactly opposite cases happen in there now. So here the red region will be shifted to carbon, blue region will be shifted toward lithium. That means so this will be a positive, this will be a negative. So just because of carbon metal bond is developed between that system, so the polarity will be reversed now. Okay, like Ampolong concept, again we have a Ampolong concept in your last semester, I think so. Okay, so again look at the second example here. This is a methyl magnesium bromide. Obviously bromine is must be more like more electron cloud system. So look at this, the electron density on the magnesium now, so it completely positive. This is negative, this is also what negative. So organometallic compounds are the source of what carbanion. They are utilized for the making of carbon carbon bonds particularly. So if I convert to this one, so now I will changes, I can changes the polarity of that system now particularly. Okay, so here these are the three different examples and the comparative polarity of that. That red region is nothing but the what higher electron density, and blue nothing but the what less electron density now. So in case of what alkyl halide, carbon is positive, the chlorine halides are what negative, but in the case of what second, so that's why look at this one. So here it will be act as a electrophilic in nature, but in this case it will be act as a nucleophilic in nature. Here also the same. Okay, so in alkyl halide carbon is a electrophilic in nature, while in methyl lithium or methyl magnesium bromide carbon is a nucleophilic in nature, and that's why it is a source of our nucleophile. Okay, is it clear? Okay, fine. Then how to identify the polarity of bond now? Likewise this one, there are the two pictures. This is for methyl fluoride. Again this region nothing but the red region where electron density is more, and this will be what the blue region, one can call as electron density will be the less. So the carbon will be act as a electrophilic character. So just to changes that system now, if we replace that methyl fluoride to methyl lithium, so here the electron density will be shifted to carbon and blue region will be at here now. So this will be act as a nucleophilic one, this will be act as a electrophilic one. So this will be simple what one can say, it is not electrophilic one can say, but the electron density will be lowered for the second structure on lithium. Okay, so I hope you will get my point what I am trying to saying that. So first you differentiate, then you will able to apply that your reagent on any concept regarding the organic synthesis. Okay, so first reagent of chemistry from organometallic system is organolithium. So this reagent is general formula is R2Li. So the general formula for this reagent is R2Li. Actually it is a present in the polymeric form, but we are take the simple molecule that is R2Li. So it is one of the most reactive reagent, and so again we are using that. So this is actually the electronegativity of what lithium, and this is the what for carbon. So the difference will be what near about 1.5. so it is a more reactive than any other organometallic compounds. Okay, remember this one. So what are the points to be considered while preparing that organolithium? So again environment should be inert, that is in absence of what oxygen, either moisture and either what oxygen, both are what absent. Okay, both should be not there, so must be inert and atmospheric air. Okay, and you know that in case of what halides must be what generally we are using iodide. Okay, iodide generally bromine is best one, then what other. So we are not using fluorine or we are not using iodine, both have some limitations. What is the purity and physical state of what the metal now? Purity. Okay, so if metal surface is clean and have one can call, if the metal surface is clean, so that means we should have the more surface area, or it will be the more surface area. That's why purity should be the most important factor for preparing this organolithium. Solvent, again hydrocarbon generally we are using that for preparing this system. And reactivity, here tertiary butyl lithiums are more reactive than secondary butyl lithium than what the n butyl lithium. So we'll see the what how to prepare that reagent via first method is halogen exchange method. So this is Rx and this is RLi. So now this will be called as a halogen exchange method. Second one, how to prepare that aryl lithium reagents now. So we have suppose I have this compound, active methylene compound, this is called as active methylene group, and I can easily substitute that hydrogen by what lithium. So I can develop this compound, and either you can also have the exchange phenomena with respect to that Br. So you will get this reagent now, and this will be just show the another reactivity. Again Br will be exchanged with lithium. So these are the methods of what lithium halogen exchange phenomena. Okay, another reaction what this bromine will be replaced by what lithium with the help of what n butyl lithium. Okay, So that means we required already prepared reagent and butyl lithium. What is that chemoselectivity now? So our organolithiums are what smaller one particularly, and so look at this one. So there are two examples are given. LDA, you know that LDA is nothing but the what? It is a non-nucleophilic, so it always abstract the proton. That's why he abstract the proton first. While RLI is a powerful nucleophile, and that's why it is attacked to the what? Carbonyl carbon. So this is the basically the difference between these two systems now. Okay. Second application, that orthometallation. What is that orthometallation? So where we are creating a new nucleophilic center on the what ortho position. Okay, so how that hydrogen will be first abstracted. Okay, and that phenomena where the hydrogen bonding and etc will be the something is ionic 6-member ring. Okay, will be developed. 5-member ring, for 6-member ring will develop, and then it will be exchanged to this one. So this is called what? The orthometallation process, where the ortho position will be active, and then that ortho position will be reacts with any electrophilic center now particularly. So that means like that, and you will get another product. So here again the same example. So H will be replaced by what? This one. Okay, then metallation of alkynes. Now how it will be now? So you know that alkynes are what? Acidic one particularly. If you have sp hybrid as hydrogen, so that hydrogen will be first abstracted by what? Organolithium. So you will get the newly formed reagent. So for that, for alkynes particularly, you require the already prepared reagent, and you know that the conditions are required for that, and you will get this product. The newly formed reagent will be developed now. What are the applications to that organolithium? So the first application is addition to carbonyl compound, converts to what? Alcohols. Addition to acid. Then third application is addition to nitriles and carbon dioxide. Then displacement of halo groups, and it will open the epoxide. This is actually flow chart of what? Organolithium, and in that flow chart there are all the applications are included. First application is what? Addition to what? Carbonyl compound. So here look at this one now. So this is carbonyl compound, converts to if formaldehyde is given, converts to primary alcohol. Acetaldehyde is given, converts to secondary alcohol. Ketone is given, converts to tertiary alcohol. So very simple example. These second application also the same for primary, secondary and tertiary. Synthesis of primary, secondary and tertiary alcohols from formaldehyde, acetaldehyde and acetone. Second application is what? Addition to ester. Now if addition to ester, that means this RLI will be reacted here, this group will be eliminated, so you can convert to ketone now. Third application is what? It abstract the hydrogen. If whenever any acidic hydrogens are there, it will abstract the proton, so byproduct should be hydrocarbon. Addition to nitrile. When addition to nitrile, just like Stephan reduction, converts to carbonyl compound. Then we have addition to carbon dioxide, CO2, most important transformation. When RLI react with CO2, first converts to carboxylate ion, lithium salt of carboxylate ion, and then finally converts to a ketone. Important reaction. Okay, and lastly, opening of epoxide must be via SN2 fashion, and sterically less crowded side should be the suppose I have this one, then it will be opens from this side. Okay, remember this point. So these are the actual flow chart of what organolithium as a versatile reagent for transforming many functional groups from one another. So we will see the one more important reactions from organolithium, that organolithiums are applicable in this reaction, that is called as the Shapiro reaction. You know that this reaction is conversion of a carbonyl compound to the alkene. Now particularly this is called as a hydrazone, tosyl hydrazone. When tosyl hydrogens are reacted with the excess amount of what? N-butyl lithium in the presence of what? Any electrophilic in nature, so it will be converted to what? A substitute product. Now alkene will be a more substituted alkene will be a developed. The mechanism is given: first abstraction of the proton from that tosyl hydrazone system, then the proton will be terminate here, that means move here. Okay, and the negative charge will be at nitrogen, then the elimination, simultaneous dianion formation will be developed now. So this is the reaction where dianionic intermediate will be there now, and after that elimination of at N2, that will be gives the product now. So this is the first your organometallic reagent. So try to solve all the type of examples with respect to your mechanism and all these things. So if any doubt regarding that, so let me know. So the group is open for a discussion, and thank you for watching this. So and I must fill the Google form. Thank you.